Welcome to our fourth Women in Hardware video. I'm here with Danielle Applestone, CEO of Bantam Tools, as well as Limor Fried, the co-founder and lead engineer of Adafruit. So stoked! And I'm Alex Glow with Hackster.io. So what is Bantam Tools?
Bantam Tools is a hardware and software company, and we build the Bantam Tools desktop PCB milling machine, and it is used for what you might think, milling PCBs on your desktop. And we focus on professional reliability and precision because we want people to be able to make their products as quickly as possible.
We have one here. I make one. I use it all the time.
Awesome.
Yay! And I've known you for a long time, actually. And when I knew you at MIT, you never talked about milling machines or CNC machines. How did you get from being an MIT student to being the CEO of Bantam Tools?
Yeah.
How is it? You're like, yeah.
Yeah, I was like, oh yeah. Well, I remember the first time, one of the first times we hung out, we were in miters at MIT, and I was working on an electronics project, my first ever electronics project, which didn't go very well. But
this was before Adafruit.
Yeah, totally. It was binaural microphones because I was really into recording music at the time, and it was a thing I read about and tried to make it work, but. I was always into making things, of course, but manually, with scroll saws, my favorite saw. And
good saw.
So after I graduated, there was this opportunity to work on a government project to build desktop-sized CNC machines for the classroom. And so I had never used a CNC machine before that point.
So you were hired into this job, and you're like, I'm going to have to figure out CNC machines.
Yeah.
And you did.
Yeah, totally. The first ever thing I milled is on YouTube. It was like a wax thing, and I was so stoked about it.
Yeah,
That's
you
cool.
mentioned that people mostly use them for PCBs, but clearly people are putting them to other uses. Like I've seen people make little pins, like lapel pins and stuff. Have you seen any other cool applications that people are using these for?
Yeah, one of my favorites is in the area, it's like biotech. So people need to build really small plastic structures with very precise grooves in them to do testing with basically it's like small volumes of liquid, mixing them together, seeing what grows in them, all kinds of stuff. So I love the kind of research end of things, but also people are using them for crafts. There's a number of jewelers who use the product to, their whole Etsy store is based around what they can make with it.
So you got this job, and you were like making stuff out of wax, and it was for education. And then how did that turn into what is now a professional tool?
Yeah. Well, we were making it for education because we were on a government grant, and their goal was to put shop class back into high schools, but this time not just welding and hand tool skill type stuff, but to teach kids digital design and CNC manufacturing. So something that was more aligned with the direction of where manufacturing was going. And that project ended kind of suddenly, and we thought, okay, well, we don't really have to go after education. Who's actually using this? And we looked around, and there were people who are already designing boards and having a board manufacturer make them. So we thought this would be a good application for the product. But even we targeted makers at first as well. But
Why?
we are makers. We were a company full of makers, and we thought, yes, it's a product for us, which was true, but it happened to be a little bit too expensive, and to really justify the cost, you need to be making a lot of boards. You need to have prototyping as part of your job every day.
It seems like perhaps you're thinking about targeting a type of manufacturing that's more distributed, sort of like the 3D hubs, but for milling. Is that right? Have you thought about this?
Yeah, we have. I think there's definitely a role for that, and depending on, of course, the size of the part that you're making, it's often easier to go with a distributed manufacturing option, but people that we work with that buy our machines, they like it like 20 minutes. They don't want to wait at all for anything. Right. So you have an idea, you mill the thing, it's 20 minutes later, you're soldering it up, and you say yes or no about whether or not it's going to work.
So a lot of sort of R&D kind of stuff. And is that what you guys use it for?
We use it, for R&D. What we do is the parts that we use for our finished products are usually too fine pitch to mill. So for those, we get PCBs done But when I make the testing jigs, so each product needs a testing jig. The testing jig I manufacture on the other mill because the testing jig often has to go through a couple revisions very, very fast. And every time I do that revision, like the product is held up because I can't release it. So if I can make it on the other mill, and I can do that in about a half an hour, and the traces are nice and big, and it's really easy to put together, and the pogo pin solder, and we got that down, we can get the product into manufacture. And then after we've verified the PCB is good, then we order like a finished PCB that's much more like long-term stable. The other mill PCBs they do last for like up to a year, but you know, once you basically get the idea down, you finish the prototype, then you can go into get them finished.
It's for prototyping.
So you were Other Machine Co. within Other Labs, and you were creating the Other Mill. Now it's now you've become Bantam Tools.
Yeah.
What are your big dreams for the future?
Well, we want to think about, you know, serving other types of engineers just as well as we serve the electrical engineers. So if you're a mechanical engineer, maybe you're an industrial engineer or industrial designer, what tools do you need for your work? Are there ways that we could make things more accessible for larger groups of engineers?
And have you been through this process before?
Well,
of sort of transmogrifying the company from what it was to sort of merging or being acquired?
No, I think this particular company, we have gone through a lot of internal identity shifts, you know, going from education specific to makers to more professional engineers.
Right.
But this is my first big company. The other company that I ran was just, you know, only 2 people.
Oh, what was
software
that?
Company. Oh, it was
Tell her.
Wait, it's called Snipe Swipe. You can look it up. I made up that name. It was it's an eBay sniping company. So me and my boyfriend at the time were hanging out at MIT, and we had joined the underwater vehicle club, but that was kind of a dysfunctional organization at the time. So he's like, let's make a company. Let's write some software. And
As
so
you do. We're bored.
Totally. It lasted 13 years.
Dang.
And so I now sold out, and I'm not a part of that company anymore. But that was the first company that I ever made.
This is back when like eBay sniping was like a really big deal.
eBay was huge.
Yeah.
I don't know if anyone will ever remember that, but it used to be really popular.
So you changed the name of the company and to Bantam, which is you have this beautiful rooster.
Yeah.
And is that like your mascot? What's going on there?
This one is just for just for the team. But the rooster is an important part of our ethos, oddly enough, the Bantam specifically.
Okay.
It's a really small one.
Or?
It's more of like a punch above your weight class type of thing, because it's a really small rooster, but it can defend itself against much larger roosters. It's like the last rooster to die.
Yeah.
Like
you used to keep roosters.
Chickens.
Oh, my.
You go into the chicken coop after like a terrible raccoon raid, and there's one thing left, and it's just the Bantam rooster, pretty much.
Okay.
That's hardcore.
So intense, aggressive, powerful, small.
Yeah, small and powerful.
Yeah.
That's what we're doing. You know, we're trying to empower small teams to be able to compete against, you know, giant product development organizations and stuff like that. So we internalize the the feeling of the Bantam at our company.
Who came up with that?
Bree Pettis, who acquired the company, and I worked with a naming company.
Oh, cool.
Yeah.
Good naming company.
It was down to the wire.
Okay.
We didn't think it was going to happen, but
Are there other names you can tell us that you didn't pick?
No, I'm not going to share.
No, because people are going to be like, oh, no, you would have been a better name.
They're not as good as that one. That one they really nailed, because it is sort of in my opinion, it's kind of like a middle of the country name. Like if you've raised chickens, you're very familiar with it, or you're familiar with boxing, like bantamweight boxing is the smaller folks. And it just felt very accessible to me. And for once, it wasn't other. Like other is kind of, well, what is other?
It's a kind of name that MIT people come up with. They're like, oh, other, and it's like that. Yeah. It's okay.
Like someone who didn't know anything
it's a meta
about
name,
marketing.
You know? So at least now you're a good brand identity. But can you tell us a little bit about the machine? Like, what are the specs? Like, why is it so good? What makes it so small and so powerful?
Yeah, it works every time. When you plug it in, you have the software, it's just going to work. You can depend upon it to do your work. And I think that there's often with CNC machines, there's a lot of setup. And this one, you don't have to do any calibration, and it'll just work, which is nice. The second thing is, you know, it does 6 mil trace in space, and people, I think you all were the first ones to do flexible PCBs, but we're seeing a lot of people try out flex PCBs because they're typically harder to get prototyped for.
They're very expensive, They're expensive to get prototyped. Not all the shops do them.
Really precise depth for that.
Yeah, but can do it. As long as you get, the hardest part is the tape that you tape down the flex PCB material has variation, so you have to make sure you get it down really flat.
Yeah.
Because that's what adds the variation. The bed is flat, the flex is flat, it's just how you adhese it. But then, you know, you can do it. We made a piece like this big.
Cool.
And we put some LEDs and we flexed it. You can do it.
You just put the tape directly on top of the flex?
Yeah.
Cool.
Yeah, so we added a bunch of features that allow you to do that a little bit easier. Now you can probe the top of your PCB or your flexible PCB. And now there's a dust collection system, which is really nice if you're doing a lot of PCBs.
Yeah.
So you can do 6 mil trace in space, and you can mill the surface of anything. You know, the resolution is 1/1000th of an inch. So if you have a coating on something that's 1/1000th of an inch, you can mill it off, shave it off. It's actually kind of interesting. We have a number of forensics departments that use that.
I was kind of wondering for like taking apart chips or other things.
Yeah, extracting chips and milling away layers
That's
and
neat.
doing physical data extraction, which, you know, people have their own feelings about. But
Oh, that's cool.
So
So,
always use a drill.
I mean, it's amazing to see cops using a CNC machine in their daily life. I'm like, this is great.
wow, that's neat. So even though it's designed for PCBs, you're actually starting to see it move into other uses and from, like you said, police work to forensics to science and technology. You know, you said microfluidics. Is this a general purpose tool, or do you think it's a specific tool for a specific task?
I think it is for PCB milling.
Okay.
All of the features point to PCB milling, but if it's around, people will generally stick other stuff in it and like just see how well it can do. People do mill aluminum with it as well, but it's not really designed for that. So you can get some results, but if you're milling PCBs, it's the way to go.
Cool. So you sort of the earliest part of the story we've heard so far is you being at MIT and like building your own binaural recording set and stuff like that. How did you get to that point?
Oh yeah. I grew up in Arkansas. I'm kind of a rural kid.
Is that how you're familiar with roosters and stuff?
Yes,
Cool.
yeah, 20 acres, 15 miles from the nearest town, kind of situation. And so I fell in love with science. I realized that it was a way to, get access to bigger parts of the world. And so I ended up at MIT and I studied chemical engineering there and music there. And from that, I wasn't really sure what I wanted to do. I didn't know what chemical engineering was when I signed up for it. So by the time I got in my senior year, I was like, oh, that's right. Not chemical engineering. You don't actually do a lot of chemistry in chemical engineering. It's mostly process. So I wanted to be more on the invent chemicals side, which is material science. So I ended up studying material science and battery chemistry and things like that.
Cool.
Yeah, and was gonna take a job at Tesla, but went and hung out with my friend Saul, and he was like, "Oh, I got this grant. You should run this grant."
Yeah, don't go hang out there.
Yeah, classic. Like, you're not gonna do that. Come hang out with me.
All right, that's cool. So some things about the machine, how do you make the machine so precise? Like, what is it that allows you to, like, mechanically, what makes the machine so able?
Yeah.
Like some of the design decisions that you made.
Yeah, there's a couple different decisions, and I didn't make any design decisions on this machine. I just made sure the company stayed in business. But the vibration is really the big key. And this machine is made out of plastic, which if you hit a thing of plastic, it's going to make a thud. If you hit a piece of metal, it's going to like ring. And that's because of the vibration. So plastic is going to absorb vibration, which is really great. And with the Bantam Tools desktop PCB milling machine, we have a spindle motor that's balanced like a hard drive. And it's balanced at all points in the RPM curve. So sometimes you'll get a motor and it's balanced, but it's only at a certain small range, or it's maximum RPM
You have to run it at 30,000 and that's it.
Exactly. Yeah. So we requested that it actually be balanced throughout the entire operating range, which is really helpful. So its resonant frequencies where it gets crazy are like much higher than we run it at. Which was kind of awesome. You can just ask for that. So really the casing and that, and also the parts that really matter on mostly the spindle, they are made by this really great company in California. So we keep our high precision parts local, so we can have really great relationships with those folks.
Because you're based in Berkeley now, right?
Yeah, that's right. And so we just buy really high quality parts. We have a really well balanced spindle that's high RPM, so you can use tiny tools. And then we also have a plastic frame.
And then I've heard that you do some of the manufacturing in Berkeley. Well, like how much do you do in-house, and why do you do that in-house?
Yeah, we have all of our components made elsewhere, but then we do sub-assembly creation in Berkeley. Like our spindle assembly comes as 30 different parts, and we put all that together.
You're not going to wind a motor by hand. It doesn't make sense. You're not good at that.
That's right. Yeah, no. Rods and the motors and the frames get manufactured elsewhere, but we do all the final assembly in-house and all the testing and stuff.
Why?
Well,
why not just send it to China? Like they'll take care of it.
Yeah.
I feel like this is a loaded question coming from you.
I don't know. I get asked that all the time.
Yeah.
Well, the number one reason is we wanted to be flexible because we didn't know what we were doing. So if you only have a small amount of money, you can't really commit to large orders of things. You can't commit to a big time relationship with a tier 1 manufacturer in China. You have to spend a little money at a time and place a lot of bets, I think, on like how are you going to do manufacturing? What is the tolerance that you need in this on this part? And so it allowed us to, first of all, gain all that expertise in-house and do all the testing in-house, so we could really verify that, like, well, why does this machine perform better than that machine? Because we had assembled it ourselves, we could actually learn, and so we iterated quickly through, over thousands of machines. We would actually make improvements to the hardware consistently throughout that, the whole 1,000 machine. There would be different batches that we made with different variations.
Ooh, mechanical things.
Yeah, it's never what you think it's going to be.
So, if I might interject, you've got kind of two models, right? You've got like a $3,100 one and like a 4K one.
Oh yeah. So we sell one with an extended warranty and kind of like all of the accessories like that you need to do the high precision stuff. So a high precision collet and nut set, which is if you imagine the end of a tool that you're milling and you're spinning really fast, the tool is going to wobble. Like every tool wobbles, but this one you're able to do high precision stuff. And there's like a high precision alignment bracket and stuff as well.
I was curious when you were talking about the precision over different speeds and the fact that it doesn't wobble so much. Like, what's the most expensive part of it? Like getting your own, like demanding very specific tolerances and things like that must get expensive, but I don't know.
It does. The frame is the most expensive part.
Really?
So yeah, not a lot of people.
Because you're like perfectly square and
Right.
And it has a bunch of features milled into it also. So all of the cable routing is like hidden and perfectly flush on the inside of the machine and stuff. So it is. It's a delicate frame. We wanted it to be that way for vibration dampening, and so that we wouldn't have to spend money on an injection mold, because like I said, we didn't really know what we were doing at first. So
injection molding has its own issues,
Yeah. So that's why the frame is the most expensive.
Cool.
So what's next for Bantam Tools? Like the future, what's there? More chickens?
It's. I would love to be in a place where we could have chickens.
Okay.
That would be pretty awesome.
I think like Brooklyn would get chickens. People keep
put them
chickens
on the roof.
Yeah. I did read something about
store them in the pipe organs.
It doesn't get that cold in Berkeley.
People are into it. I think it's a craze now in Silicon Valley for CEOs to have chickens or something.
I just read an article about that. They put little outfits on them and stuff.
Like you don't have enough problems already. You gotta get some like wild animals. What's next for Bantam Tools?
Well, we know that our biggest strength is actually our ease of use. The software is super easy, and so we're thinking about how could we take that and apply it to different machines for different groups of people. And like I mentioned before, what does the mechanical engineer need? What's their first, what's the first thing they go to do whenever they have an idea? Is it 3D printing? Is it some other kind of machine? So we want to build on this ease of use, see if there's other products that we could offer to make it possible for anyone to make whatever it is that they can think of.
Cool.
I asked all my questions. Is there any other questions you want to ask?
Just a sort of random one where you've got people will use like multiple axis mills for doing really 3D milling, and you seem to be mostly in about 2 to 2.5D if you like count the like sort of stacked.
Yeah, one
2D
axis,
things.
just up and down, left, right.
Do people mostly just stick to those things, or?
Primarily, 3-axis is the most common. 4th axis is much more of like a craftsman style thing, like custom pens or legs for tables and stuff like that. And 5th axis is jewelry and teeth and sort of like the more complicated things. Like if you wanted to 3D print something like with that complexity, but you wanted to make it out of metal, you could go to a metal 3D printer, or you could have like a 5-axis milling machine.
Do you have any plans to expand to more axes on the Bantam tools?
Well, we're thinking about, what is it that people really need? Because we don't want to be a solution in search of a problem. We want to find the problem first.
Right.
So that's what we're actively looking for.
Cool.
I know you'll do it small and powerful, like a little chicken. So, okay, so people want to get more information about Bantam tools. Where can they find out how to purchase this small yet powerful machine?
Yeah, they can go to bantamtools.com.
And that's it.